All right, hello. Here we are in Section 3, Week 2, the first video. Last week, we focused on actor manager, health, damageable, and then those three scripts of the compass. So either on a player or enemy, it doesn't matter. But we went down into the actor script, and we looked at the game manager, what's happening with the actor manager, and then we went and looked at damageable, which is connected to health, which kind of they should be next to each other component wise, but these two are really important, and they also all of that also involves the enemies. And then last week we spent basically the whole. I mean, not last week. The last video, the last class, we spent the whole time on this, the compass. So the parts of it that dealt with that were, oh, the player doesn't have a compass element on it. Yep. So the compass element, everything that's going to appear up in the compass needs to have a compass element. So the enemy's got one, and it's pointing to this prefab that needs to get created, this thing. And this will get created underneath the compass UI part here. And between the compass script, the script that's on here, compass marker, and the script that's on an enemy or whatever else you want to appear on the compass, you have compass element. So those three scripts, that was it for the whole class. And then I did, while going through them, I did have to talk quite a bit about vector operations. I think it was mostly in compass. Yeah, we loop through each element in the dictionary, and we do a whole bunch of vector operations to figure out where to place our little 2D graphic in this little 2D rectangle based on like where the player is oriented, and where the enemy is in relation to the player orientation and how far apart they are from everything. And so we went over a lot of vector ideas like normalize and magnitude and subtraction or arithmetic, and project on plane. And those are all really important in the dot product. And that's what I was just saying, like everything of this might feel weird and be like, oh, this isn't fun. But trust me, the more you get acclimated to it, just the more comfortable you are with it, and just the more intense you'll be as a game developer, because this is behind the scenes, like all your thinking. The more you can understand these concepts and like apply them naturally as you're thinking and coding, just the more ideas you can express in game development. I was saying that all the tools that you're using, with nice little GUI interfaces and make everything simple for you, they're doing this behind the scenes, and then you're only confined to like whatever the tool allows you to do, which is just code like this behind the scenes. So the more you understand it, the more you can customize it, just the more game ideas you can produce in game production. So just take your time with this stuff. And I'm more interested in like the concepts and how they're being implemented in this code as like an example. Like you don't always have to understand the math or how to like write the code to make it happen, but you should be able to look at the code, and look at the concepts I was showing you, look at the images that I was showing you on Google search, to get a rough idea of what's happening with this type of vector math, and then look at the code and be like, oh, okay, I kind of get an idea of what they're doing and why they're doing it. Even though you might be able to not exactly, like replicate it. So that's why on the quizzes I ask about the rough concepts, but I also ask about like, well, if you look in this code here, file, or if you look in the script file or in this little block of code, what do you think is happening or why they do that at a kind of a higher level? Now there's a few reasons for that, but you can't. It's almost a mix of like understanding theory and concepts and just understanding some basic implementation of it. Like, well, ultimately, what I'm really trying to get across is like code, not legibility, but literacy. Computer code is like another. I mean, it's built to look kind of like natural language, and it's almost like just learning another language. It just relies almost exclusively on like logic and math. And just the more that you get exposed to it, and the more that you can kind of sit there and watch somebody read it, or then you can start to read it. It's just you can understand that these are just developers expressing their ideas for a gaming project, and that's ultimately the first step where you can start to express your own ideas. So that's why I just spend a lot of time reading through the code and explaining what's happening and what the developer is trying to express. And sometimes their code might be convoluted. It might not be the best way to approach a problem, but that's also part of the field. It's like there's an infinite number of ways to solve problems, and code is ultimately like a language that you're communicating your ideas that get interpreted into machine code. So looking how others are expressing their ideas, and then thinking about how you would express them, that's more attuned to how you're thinking, or it might be simpler to approach the concepts, and how you rewrite it is a huge skill set and learning opportunity. So that's why I spend my time in this area with my classes, and this is why I kind of build the quiz questions like that. Just I've gotten some questions back, so I thought I would explain that I'm not asking you to write the code or to understand the concepts in depth, but what I do expect is that you spend enough time messing around with the project, getting your hands dirty, that the high level understanding of the concepts can you can understand the concepts at a high level, and then you can also understand how they're being implemented in these examples at a high level. So I expect you to have opened up the projects and opened up the code files and messed around with them and tried to change stuff, and it's going to break, and that's okay. But I expect you to get your hands dirty, like computer science or game programming, and what's happening in the game engine. This isn't a theory class. I have to introduce theory because there's new concepts I have to bring up to you, but then ultimately I dive in and show you how those concepts are being used in code and in engineering. So it's not just science or concepts, like it's being directly applied. This isn't applied science. It's not like a math or like a physics. And so anyway, actually, I had a student I was working with. I had him working with on a project to learn the different areas of computer science, and he really, it was interesting because he didn't he likes the field, but he likes like the theoretical aspect of it almost, and he didn't like the engineering aspect of it. I'm like, well, in computer science, it isn't really like an ivory tower science. It's not something where you could just stay in the books, in theory. I mean, there are some applications in academia with that, but on the whole, this is a very engineering based, very applied based field. And that's why I kind of do two things at once. I'm explaining concepts, but showing it in code. And even if it's ugly code or maybe a little bit over engineered, it doesn't matter, because you're going to be working with other people. You're going to find this is like it's a team sport almost as well. There's no kind of idea of a lone wolf. You always have to work in at least small teams. So you're going to have to get exposed to other people's, even if it's not the code, but the way that they built the Unity scenes or the project. And you just have to get used to seeing through other people's interpretations to understand what's happening. So anyway, just a quick, explanation of why the classes are focused like this. In any case, actor, animate, manager, damageable health. These were all last Tuesday. This compass element, compass marker, compass. This was all on Friday, and along with a lot of ideas and implementation of vector threes. And based on where we kind of left off, we kind of touched base on the enemy controllers. We just touched them ever so slightly with Compass because we registered with their events so that we could change their color dots from like orange to red. And now's a good time to move into the enemy controller. My big areas I'm thinking of are the enemy controller and then the weapon manager and the weapon prefabs. And just looking at the time, I'll probably go I'll definitely fill up 1 week, 2 week, and then I'll see if there's any little bits and knobs that anyone wants to touch on in the project before we move on here in section 4 into the racing car game. In any case, enemy hoverbot and enemy turret have this enemy controller, and they're underneath their hierarchy is going to be different. Still have like a 3D health bar in the world, UI element in the world. And at this detection module, I have to forget to cover. This is interacting with the enemy controller. You can see it here. And the hoverbot has this hitbox where it has damageable down there. And let's see if damageable... No, damageable isn't on the top level here. Okay, the hitbox happens to be thrown underneath the model. I think that's this should probably be pulled up because it's kind of hidden. So if you click here, this is the beginning of like this whole animatable 3D model. And this gets kind of hidden from my perspective anyway. But anyway, that's where you'd find all the parts for each. And let's look at the enemy controller script. We should look at the animators too. There's quite a bit to enemies, but since we touched, let me just start from the top here. The enemy controller, and I don't think we're gonna hit everything with these enemy prefabs, but let's take a look. So enemy controller. I was just looking up here. We're kind of done with compass. I'll keep compass element just because it's sitting on the enemy. I'll get rid of this. These are all basically sitting on the top of the enemy prefab. So enemy controller. So notice require component. So this means there better be other components of type health, actor, and nav mesh agent sitting at this top level, or else it's saying like I will not connect as a component onto this game object. So this is interesting. Like if you want to make sure there's all those components because they're going to be referenced down here. So you better make sure that they're connected up first. Name is enemy controller. So I'm gonna skip this for right now, and maybe we'll hit this a little later. It's I will note that this is a class, and usually there's one class per script file. But notice that this is now declaring a public struct. All right, and then there's even stuff within it. So a class and a struct are very similar. A class just means it's like a blueprint. You can create objects from it, and those objects may contain fields and or methods. You can put in fields or not. You can put in methods or not. More often than not, a class will contain both fields and methods. Now a struct is actually comes from the C world, and it basically means a simplified class. Usually means like it's data that's a little bit more complicated. Like it's just not a field. It won't be like a float, an int, or bool, but it needs a few different fields. So in this case, we have like this render and this integer variable or field. Well, they're public, so they're properties. But usually they don't have methods. The big separation is classes, fields, and methods. A struct just has fields. There's just many fields because it's representing something that's a little bit more complex, but not as complex as something that needs a class. And normally it means you just have fields and properties, just not methods. Although you can have methods, and here's the method. Render index. So this is basically like, okay, good. So this is what you would call a constructor. So notice that this method name is the same as the struct. So this is a little different where normally we're making classes that are inheriting from mono behavior, and they're like components. They go on as components on our game objects. This is saying, hey, within this class, we're also going to define a struct called renderable index data. And let me just see where. Okay, so ultimately they make a list of these things and all the different body renders on it. Okay. Now this thing can contain links to a render and an integer. And this is what's known as a constructor. So technically this is not a method. Like you wouldn't say, hey, when you create, so anyway, you can create objects of type struct, just like you create objects of type class. So you can define different types of structs and make objects from them, just like you can with classes, but they're simpler in that they don't have methods. Now this is not a method, even though it's structured like one, since it's named the same as the object that the blueprint, the struct that we're building. This is what's called a constructor, and in all other like all other like programming language situations, including C#, normally when you create a class, you have to define the constructors. It's just in when we're working in Unity, it's like a special flavor of C#. It's modified a little bit, so you don't have this idea of constructors. But the constructors are big regular idea in programming, and basically it says, how do I build, when you want me to build an object of this, how do I build it? Well, you call a constructor. You define how to build it. So basically it just says, whenever you want to create a new object of type render index data, you just have to pass in, when you're going to say like new render index data, and you're going to use these like smooth brackets, these parentheses, you have to pass in a reference to some type of render and integer. And this is what it's saying is like, okay, whatever is coming in, whatever input came in, just set my property to that. And then set my property to that and consider me constructed. Consider me a new object ready to go. So that's the idea of a constructor. And they're just hidden from you. There are constructors going on here. It's hidden for simplicity for Unity developers. So, interestingly, okay, so here's one that's being created, a member variable. Okay, so here it's being, we'll get to this code eventually, but whatever we're looping through somewhere, it's saying, hey, create a new renderable index data, a struct. And here, see, like it's passing in these two variables. And so this is the constructor is being called. All right. So sometimes, so that's the idea of a struct. That's the idea of a constructor. And in this case, the developer wanted to use a struct to represent this information. and meaning it's something that basically has two properties associated with it, because they didn't want to like create these properties separately because they want combined for one render index data object. So they made a struct, and they define this thing within a class because we're gonna use it here. So it's part of this class. And then notice there's system serializable data. System serializable. So let me just see. So it's creating a member object of it. So normally when something is serializable, when it's a little complicated like that, you need to make it serializable if you want it to show out here in the inspector. But it looks like I'm just seeing if they're like at runtime, you can see all these renderable objects. Like sometimes they'll like show them in the inspector for like debug reasons, but I don't see that. So it might be that if you're gonna like, it looks like they're adding this to like a list and stuff. So you might have to use this, make it a serializable object if you're gonna start throwing these structs in a list. But in either case, so we have a bunch of properties that are exposed on the inspector, and we have like little tooltips and headers being shown for them, so it's easy to understand what all this stuff is. Here we have some events. So when this enemy is going to be attacking, detecting target, losing target, damaged. Here's a new list of these renderable index data. So for some reason they have to create a list of all the renderable objects. So in here, I don't think it's going to be. Oh, he's got a weapon controller too. Cool. I didn't know the enemies had a weapon controller with the player. So this is dealing with the weapon, but so here we have like parts like of the mesh. Let me zoom in. So here's like the bottom, and if you notice here, it has a material on it. So this is a renderable object. You can turn off. We have the big eye in the middle, and we got the top part. And underneath here is what's called the skeleton. We're not working in a content package, but if you wanted to animate stuff, we have this idea of a bone system. And when you want like elaborate character animations, or usually most any type of 3D animation that's coming into a game engine, somebody was in a content package like a Maya, Max, Houdini, Cinema 4D, and they were like making the 3D model, they were like texturing it, adding a material to it, and they were like they call it skinning it to a bone system, and rigging, and then you can like animate those bones. So we'll look at how the animations are playing back a little later, but just to know the structure of the prefab, the game object. But anyway, here's like these material objects, these renderables that are probably being stored up. For some reason, I guess they need access to all the renderers that are making up the body. Looks like there's about 3 of them, and they mess around with them in some way. Like the eye is going to be flashing, and I think that's what has to do with this. And like here's the eye data too, specifically for the eye. So anyway, patrol path. So if it's like supposed to be moving around, so the hoverbot will have, usually most likely we have a patrol path, and the turret will not. So I'll just say enemy mobile, nav mesh, compass element. Let me just double check. Pretty sure he patrols. Yeah, he's moving. Okay. That's all I want to know. So figure out what the patrol path is that's going on. So known detected target. So look at this detected target, targets in range. These is all coming from the detection module, which was on that that child game object. Sorry. Down here. And a bunch of fields, private stuff. 1 second. Sorry about that. All right, so on start, go out, get the enemy manager, actors manager. We haven't seen the enemy manager yet. You know about the actor manager. Register yourself with the enemy manager. Go get your health component, actor, nav mesh. Go find the game flow manager. It's all a bunch of stuff going on here. So go to the health component, and looks like we're subscribing to on die on damage. We've looked at health already, but there is an on die and on damaged functions. That these are the functions that'll be tied. That'll be called when the health script fires its events for on damaged and on die. And let's see. So we got the weapon manager going on here a bit. Find, initialize all weapons, get the current weapon, show the weapon. A lot of this will probably be similar for the player manager. Oh, no, I think, we'll take a look because maybe not. So find the detection module that's somewhere in the child game objects. And then register 2-3 events on the detection module. So undetected, unlost. And this is interesting. So go out to the detection module and subscribe my 2 events to subscribe my 2 methods to the detection module's 2 events. That's what's happening in these 2 lines. And then this is a reverse. Then say, hey, go find the detection module's on attack method. Let me make sure I have this right. And subscribe to my on attack. So it's a little, you're going into somebody else's object and saying, hey, you will listen to my event. So it's a little backwards. You're not really supposed to do that. Sorry, let me just double check that. Update. Right now I'm in the detection module. Oh no, oops, sorry. Let me open up detection module. And what I wanted to find was, yeah, on attack. Okay. Start, handle target detection. Yeah, on attack. All right. So sometimes they'll do that. I guess the detection module doesn't know about the enemy control. No, it doesn't. All right. So it's a little like you're not really supposed to do that, but I guess they're like, oh, I don't feel like going into the detection module and then like going to find the enemy controller and listening to one of their events. So it's like saying, hey, the enemy controller has this on attack event, this unity action, and we're going to go into another object and subscribe its method to. This better be public. Let me just double check. Yeah, it is public. All right. We'll look at detection module later. But anyway, so some connecting up of events. Hey, I want to listen to these 2 and go, and I want that person to listen to my event there. And then go find the navigation module. Go into the children. Interesting. Pretty sure the nav module is the nav mesh agent. I don't know, navigation module. No, it's a code that they've written. So I can see it's an AI navigation module. Sorry, let's check real quick. AI, yeah, there's a navigation module right here. What's a cool thing is you can right click on an asset and you can say find references in scene. And then up here, and there's none. Okay, nobody's using it. So you can like hunt in the hierarchy, like go through the game objects, find me a component of this, and it didn't find any. So nobody's using this navigation module. So handle if duplicate. Oh, is it? Hold on one second. Is detection module inheriting from? No, it's inheriting from model behavior. Okay. Just want to double check and that. Yeah, unless it's creating it on the fly somewhere. No, get components. So this would be like null. Handle if duplicates. Detection module, enemy controller. Yeah, override the nav mesh agent data. Okay. Now look into it. So this script is not on anything. And it's kind of an empty script too. It just you set some things on it. So anyway, I'll keep reading. I'll see if I stumble upon that, but it doesn't seem to be doing much at the moment. But there is stuff going on here. I have a feeling the nav mesh. I feel like somehow this is getting connected with the nav mesh agent. Anyway, so let's see. Go through all the components and the children and grab me all the renderers. So I showed you where the renderers are, and then for each that has a shared material. All right. So basically, it's just separating out like if it's something that's using the eye color material, then put it over here. And if it's using the body material, then put it over here. All right. I'm not, so they kind of get a little, I remember from last year, they get a little elaborate with the how they're handling rendering components. So I kind of don't want to get, it kind of pulls you into rabbit holes of that I don't think are too beneficial. So I kind of might gloss over that. But it's just basically, it's like how to, ultimately what they want to do is how do they know that there's a default eye color, and like when they found an enemy, how do they change that eye color? So if I run up to him, you'll see him like get excited. He'll play some animation, and the eye color will change, like he's focusing in on you. See that he bounces, and then he kind of opens up, and then the eye gets really big and red, and there's like a little exclamation mark above him. So you see right here the default, the eye color is like, it's kind of like there's an engine in here and there's some like power going on, but he's not really, he's like in patrol mode, and then when he sees you it turns like a bright reddish. So like all this code is basically just to mess with that, which is rather elaborate in my, so I'm gonna gloss over that. So an update. So ensure that we're within level bounds. Okay, so do some checks. Basically, it's just a Y check. If you fell off somehow, just destroy yourself. Sure. So now we're jumping over to the detection module like right away. So we'll go take. I don't want to jump into another. I'm gonna try to not get too complicated too quickly, but it looks like we're jumping into the detection module and doing some stuff. So figure out a color, evaluate, calculate color at a given time. So the current time of the game running, number of seconds that we've been running the game, minus the last time that you were damaged. Okay, and which would be like nothing at the beginning of the game. So this number gets like really big divided by flash on hit duration. So I guess when you get hit, this number becomes this number, and this becomes like more of like a 0 than a 1, and like you'll get hit to another color, and you'll like ramp back to your color, or the enemy will ramp from damage color to normal color over just amount of time when they get hit. All right, and it looks like they all looks like the whole body flashes. So let me just shoot him real quick. Let me just confirm that he kind of gets a bright white or something when he gets hit, and he kind of tones back to his normal color. Yeah, okay. You see that he kind of gets white, and then he plays an animation, and he gets this white pulse color, and then he kind of fades really quickly back to his normal color. That's how they're doing that here. So that's why I had to loop through and grab like all the body renders and make it white. So besides messing with the eye, then they mess with the body renders when they get hit, the eyes for targeting you. And it looks like this is just being set to false at the end. So they're somehow, maybe this is getting calculated somewhere else, and then at the end we've done our calculate. So let's reset it. Cool. So these look to be methods that were only called by another event. So on die on damaged, and then where's it listening? Here you go. On detected target, on lost target. Yes, these are methods that are only being called. So when the detection module fires off events, like on lost, this get called. So it looks like it has its own method, and it's invoking. Let me just double check that. Yeah, on lost target. So what's happening? I'm trying to debate if I should say this is good or bad practice, but so it looks like the detection module, somehow figures out when they've lost their target, and will fire off an event, the on lost target. And it looks like the enemy controller was listening to it, right? And this method gets called when the detection module realizes it was tracking you, but it's not tracking the player anymore. And the first thing that the player does is it fires off its own event, basically of the same name. And so there might be, maybe the enemy controller is only listening to the navigation module, and then the enemy controller is like announcing to anyone else, any other scripts on the enemy, that they've lost their target. Maybe like the animation controller and like the navigation, go back to your patrol path and play some other animation. Maybe they didn't want other controllers, all of them, like aware of and connected to the navigation module, and they just wanted to funnel the events up into the enemy controller, and then anyone else can listen to the enemy controller. That's kind of I'll say that's kind of acceptable. You just don't want everyone like connected up and referencing every other component object. Maybe the enemy controller is just the funneling point. So I can kind of see the rationale there. Managing events is complicated. So when you lost your target, make your eye dim back to normal. So on detected target, let everyone else know that you've received an event from the navigation module, and brighten up your eye, make it that attack eye color. And here's looks to be some like helper methods. Helper methods are like other methods, I'll call them. And you'll like reference the code a lot. You want to like kind of section it off and put it in its own method. So we have like orient towards. So make sure the robot turns toward whatever, usually the player. And is path valid. Reset path, set path destination. Okay, a lot of pathing stuff. Set the nav destination, update path destination. All right, on damaged and on die, these are methods that are listening to the health script events. On draw gizmos selected. This is meant for debugging, and usually when you're drawing gizmos, it's this is what's called like editor scripting as opposed to like runtime. Like there's code that most of your code is written for runtime. It's written for like play time for the player logic, for the player to engage your game. But for you to like debug stuff and understand what's happening, sometimes you'll write editor scripting. It's more code that's run in the editor, and you'll like draw stuff to see like what's happening. So so like this happens to be like trying to draw the path for path reaching range, and if there is a detection module, show the detection range and the attack range. Let me just click on him, because I do remember there was some debugging. You could see like these big spheres around him. Debug display. Maybe this is only during runtime. Let me see. No, it's not in the game view. The debugging stuff isn't. Okay. So when they say drawing gizmos and you're using this gizmos class, this is more stuff you see. See, notice it says like in the scene view. It's not in the game view, and it's only usually just run in the editor. But it's not showing for some reason. I see like 0 references to it. So usually there's like a debug bool, and like in the update loop, like, oh, we'll call this. Let me just call it in the update real quick. Or you should just be aware of what editor scripting and debugging. I'm just surprised that they put that there, and then they never used it. It's just a little weird. Let me just see. And usually you can see this. You can see the debug drawing not in play mode, so it wouldn't be in the update loop. But just giving it a quick try. Nope. Usually you'd see like a big sphere around them. Oh well. And let's see, our damage on die. On draw gizmos selected. Somehow this got to be turned on, but I'll figure it out later. So orient weapon towards and try attack. So this must be the detection module or the animation. But we'll see like where this elements of the AI, like try and attack your enemy. Try and drop it. So when you get destroyed, you figure out if you need to drop some loot item. Find and initialize the weapons. This happened up above in like starter awake. So go find the weapon controller and go make all those weapons their property of owner. Make it the game object, the enemy top of the enemy prefab. All right, get the current weapon, set weapon. All right, so there's a lot of like, some of them are public, some of them are internal. And so there's a lot going. So for example, this set current weapon, this is being called here, but it's private because it's being called within the object, but somebody is calling this out in the public. So anyway, it seems like more than half of this code is kind of sitting there waiting for other scripts to manipulate it. So should I go to mobile, or since we were kind of being exposed a bit to detection module, let me fly through here real quick. All right, detection module, and then let me show you what it looks like. So it is here, and we have a detection range of like 20 meters, attack range of 10 meters, known target timeout. So after 12 seconds, then they haven't seen you after they've been activated, then they go back to just patrolling. Wait, did I notice? Okay, the animator is there. I just want to see if there's some type of animation controller. So we have enemy mobile. They're just doing the animator. Okay. Just double check there's nothing else. We have this nav mesh agent. Okay. Oh, it's after this is just enemy mobile and understanding the nav mesh agent. Okay, cool. Detection module. So we looked at these properties. And then here's our two actions, events. So I'm detected, I'm lost. Some other stuff here. There's a constant string. Notice it's K for constant. Member means it's private. K is for constant. This is what this person is using conventions, and then capital letters for properties. And so attack and not damage, short. So let's see, go out and get the actors manager. And then we have, let's see, handle target detection. Okay, was that, I think that was in EnemyController. Yeah. So is this an update? Okay, so within the update, remember I said, I kind of glazed over this, and then I said, let's look at it. So here, every update loop, we're handling target detection. We're passing in the EnemyController as an actor and any of its self-colliders. All right. So if there's a known detected target, which this is probably null. Looks like it's null, but to start off, it's just empty. It's null. So this would be false. But once we do target, the only appropriate target for the enemy would be the player right now. So basically it's saying, hey, if we've targeted the player and we're not seeing the target at this frame, and the game time minus the time since last seen the target is greater than the known target timeout, which was 12 seconds, then we just set our target to null. We've lost them. So find the closest visible hostile actor. Okay. So you can only, if there was more than one player, you would only be able to look at who's closest to you and target them. So detection range, I think it was 20 meters. So 20 by 20. So we have a square detection range. It's 400 square meters. And we're not currently seeing the target. And so this is normal. When we looking to find the closest, we're looping through everything, and we're trying to find the closest person. It's usually, this is kind of convention. I know it looks weird, but our current closest target is infinity. Because when you'll see in the loop, when we start checking, we'll say like, hey, is this, whatever we're currently looking at, is it closer than whoever we found to be closest? So to set this up for the first time, you want the first thing that you find to then be the closest. And so to do that, no matter their distance, it has to be acceptable. And when you have an unknown amount of distance, you'll say, hey, let's set our when we're first starting off, our closest distance is infinity, because we're just going to accept the first thing, and then we can check against subsequent ones. And that also means the opposite. When you want to find the furthest thing, then when you set your variable at first, it's usually like set to 0. Just so you know, like it's almost the opposite. So say we're looking for something that's closest. Well, you're going to default your checking acceptability thing to something large. And if you're looking for something far away or something big, you're going to set your checking variable to something small. So that's why it's infinity. And this is like the farthest possible, the largest possible number that a float can accept. So then we're actually going to loop. We're actually going to the actors manager in the actors list, and we're going to, for each, we're going to loop through all the elements in the list, right? And for each element that we're checking, is their affiliation not our affiliation? So the enemy was maybe a 1 or a 2, and the player was the opposite number. Then you know, like, hey, if the enemy is just processing through enemies, you're like, forget it. Don't even do any logic because they're on my team. If this whatever I'm currently processing is not on my team, let's go and look at what's happening here. So then we say, okay, take this other actor that we're currently checking, get the position, the world position, and subtract our position, the current enemy that's doing this AI logic. And so now we've done vector subtraction before, right? So this tells us not only how far away is this person, but also the direction of this person. But we're not really interested in the direction right now. So that's why this square magnitude. So this is, besides magnitude, we have the square magnitude as well. So whatever the distance, the length of this vector, you can also just return it in a square format. Okay, they're just doing that. So, and then if this square distance is less than our detection range, which happens to be 400 meters, and this number is less than closest. So if this is the first element in the list, this will be infinity. So this will be true. We'll say, yes, this is the first element that we found is closest to us, because anything is closer than infinity. And check for obstructions. So even if the player happens to be close enough, oh, you know why it's not showing? Because the debug. I'm sorry, the debugging was turned off. So I don't need to, just for anyone who is messing around with their code, you don't have to do this here. It is already working. So this is a special function, and that's why it's like colored differently. This is coming from the Uni engine, coming from mono behavior. So if you have a function that's named like this, notice it's a different color. This is specific for drawing gizmos in the scene view. And that's, I had the gizmo. This is important to note. Should we be drawing any gizmos or not? Sometimes they're just annoying and making your view distracting. You turn them off. So this is his this big sphere is his detection range. So draw wire sphere. First we set the color that whatever we want to draw, and then we say, hey, we want to draw a wire sphere at this position, the enemy's position, and this size. And it looks like this size is usually these little markers. Okay, 2 meters. So just the way that the debugging, the gizmos work is you have to define a color, and then you say I'm going to draw some type of shape. So notice it's like, okay, here's the color, now draw this thing. Here's the color, now draw this thing. And if you ever mess around with any like computer graphic packages, especially there's a lot in JavaScript for web, and a lot, God, I forget the name of it, processing, and a few others that are really big in the community. Just know that like this is, if you ever see code like this is standard for like computer graphics. You like, oh, give me this color and then draw this. And if you ever do like OpenGL and stuff, like actual graphics programming, this structure might start to look familiar. Just notice it might look a little different than standard Unity code. So, okay, so now we're seeing the actual detection range here. So notice that the player is outside, but if the enemy is here, the player is within detection range, but it's through a wall, right? So that's why it was, this next check is saying, okay, if this thing is not on your team and it's within a close enough distance, then we have to shoot out a physics raycast from where we are and then shoot along the vector. So take the actor, subtract where we are, and normalize it. This is a directional vector from us to the player, from the enemy to the player. And this should look familiar. We have some subtraction, normalize it. So it's just giving us the direction to shoot the physics at. So start at this point. Here's the direction. And how far you should shoot this physics ray out. This is how big the detection range is. And so make a new raycast hit. Take the distance to infinity. False for each hit and hits. Okay, so this physics raycast returns an array of hits. And then we say for each hit in hits, there might be none, there might be many. We check that we're not colliding our self colliders that are on the enemy. So if whatever we're processing right now is not a collision with a collider that's on the enemy, and whatever we just hit with our physics ray is less than the closest valid hit, this one here, then we know that we found a hit. And if we found a hit, then take the collider. There's an actor. Okay. So so this one is like our sanity check, and then the distance on it is set to infinity. Again, we're looking for the closest hit. So remember when I said we have to, when we loop through a series of collections, we're checking what's closest, we need to start with infinity. So what's happening here is if the enemy's here and the player's here, and we shoot a ray out, we might hit some colliders that are on the enemy. And let's just say we hit a few colliders on the wall, and we hit some colliders that are on the player, right? We know that we're going to filter out the colliders on the enemy. And then we're somehow going to cycle through the hits, and we're going to find that the hit closest to us wasn't a collider that was on this actor. So meaning, no, like this is not an acceptable situation where we found the player, just ignore it. But if we're like this and we shoot a ray out and we ignore our colliders and we hit a bunch of player colliders and now we hit a bunch of environment colliders, the closest collider that we're going to process will be something on the player, and we'll say that, yep, that's this is an acceptable actor, and they're within our viewing range. There's no other colliders between us. This is now my target. So that's basically what this logic is saying. So that's why we're looping through the hits, and as long as this is not a collider on us, and the distance on this hit is less than the closest valid distance, which is infinity to start with, which the first one we process, sure, we're good. And we found a valid hit, and then we loop through. Okay, yeah, we loop through, and ultimately what happens is, of all the physics hits, all the other colliders that we've hit to, we're going to store the closest one, which includes environments and players and enemies and everyone else. But whatever the closest in that direction, boom, I've got it right here. And so we found something, right? We just don't know. It's a valid physics hit. We just don't know if it's something that we should be targeting or not. So then what do? Whatever this closest valid hit was, grab its collider, and then see if there's a component in there that is the actor component. So the players and the enemies have this actor component, right? And then if the hit actor was this other actor, meaning, and when we initially hunted out through the list of actors, and we said, "Ooh, here's a good actor. This actor is not on our team. They're within our detection range. That's perfect. Let's remember who this is. Let's shoot out a collider, a physics ray, from where I am to they are, and we're going to hit a bunch of colliders. And let's see what the closest one is that's not any of my self colliders." And that's what this check is saying. I found somebody I want to target, and I shot a ray out, and then I found the closest physics collider through that ray cast. And then, are they the same collider? And if it is, bingo, my enemy is within my detection range, and there's nothing in between me and them. There's no wall. So you're seeing the target, and you're setting their distance from you, and you're setting the time that you've seen them, and you're grabbing their aim point, and then that's their known detected target. So that was a lot to process. Let me know if you have any questions on it, but we're doing like a double check almost. Sort through all the actors in the actor manager list, and if any of them are on the opposite team and within my detection points, then we're good. We can continue processing, see if we should go after them. Then we have to shoot a physics ray out, and for all the hits, we got to find the closest one that is not any of my self colliders. And if that collider is part of that actor that I'm currently trying to target, then yes, bingo, meaning my enemy is within my range and there's no obstacles between us. Then I can target them. And after all that, that's a lot, but we're actually still in this handle target detection method. So then we say, okay, if known detected target is not null, and the distance from me to this target, valid target, is less than my attack range, then this will become true. Otherwise, false. So if I didn't have a target in the previous frame, and I now have a target, I can fire my event on detect. And if I had a target in the last frame and now I don't have a target, I can fire my on lost target event. And remember if we already knew a target for the next frame. Okay, now that we're done with our processing for this frame, we can say, hey, if our known detected target is not null for this frame, meaning we know an enemy right now, then store this and had known target, because we're going to go through the next event loop, and we're going to run through this logic again, and we need to know the last frame where we actually had a known target or not. All right, so all this boils down to on detect and on lost target, and I'm going to have to wrap up soon, and those two get called by the enemy controller, and it's not down here. Here we go. On lost target, go tell everyone else who's interested that we lost our target. It just changes the eye color. But I bet, I'm going to stop here, but I bet who else is listening to this? Who's listening to undetected target? The detection. Right. Okay. Undetected target. So there must be some. Yeah, up here. Who else? Let's be listening to that. I'm just going to look in Enemy Mobile real quick, then I'm going to shut down this lecture. So go get me the enemy controller. Yeah, here you go. Enemy Mobile script is saying, go get me the enemy controller on start, and I want to listen to its on attack, undetected, unlost. Notice it's all listening to EnemyController, not that detection module. And so it must be doing a bunch of stuff like setting the animation, and then either moving the enemy towards you or figuring out if it needs to fire or what have you. Was there a weapon? Okay, and then there must be some interaction with the weapon controller at a certain point, like if it's in fire range. Okay, cool. So I'll move on into. I gotta move on into the enemy mobile and the weapon controller for next class. Cool. I'm gonna stop my lecture now, and let me know if you have any questions.